Hello students, today we're going to look at the triangle midsegment theorem. So let's go ahead and real quick, we're just going to knock it out without too much worrying about it. Right now we are given a triangle with a lot of crazy letters and numbers, so before we do anything else, we're going to go ahead and start drawing the thing. So we're going to label some stuff. It's a midpoint of TU. That means that this is equal to that. So TW and UT are going to be the same length. X is going to be the exact same for segment UV. They're going to be the same length from X. So if WXU as an angle is 68 minus 3X and TVX is 84 minus 7X, then what is the measure of WXU? Now, what we can know, first thing here, is whenever we slice up a triangle like this, since we have these two things at our midpoints, we know that that triangle is actually going to be similar to the one that we make when we actually grab the entire thing. Meaning, since this angle is the same and we have the ratio of this side to that side, um, both, since they're both half of this side and this side respectively, then our side angle side shows us that these triangles are similar. Now, what that means is that the red angles are the same as each other, and the blue angles are the same as each other. Now, what we are given are two blue angles, WXU and TVX. And since they are on the same side of the triangle, we know they are going to be the same angle. So we know that 68 minus 3x equals 84 minus 7x. All we need to do now is rearrange and solve. Move this over, move that over. We get 4x equals 16. So we have x equals 4. And we're going to go ahead and plug that back into this equation to see if it solves out the same way. 68 minus 3 fours is 68 minus 12, which is equal to 56. 84 minus 7x is 84 minus 28, which is also 56. So right there, all we need to do, since we've shown that the angles are the same, and they're supposed to be, we're just going to put in that angle measure. So 56 is going to be our answer. So moving forward, our mid-segment says, since the mid-segment is always parallel to the third side, corresponding angles are congruent. That's kind of our main meat of this lesson. So if RS, okay, so we've got a mid-segment here. It's called the triangle mid-segment theorem. So for all of these problems in this particular section, we're going to have this being a midpoint, and that being a midpoint, meaning that the segment here is going to be parallel to the segment here, giving us the same properties as last time. So if RS, the side, is 5x minus 39, and NQ is 4x minus 18, what is the measure of RS? So by the way, here is the other side of the mid-segment theorem. Let me actually just get things in the right order real quick. Boom. So we know that the angles are going to be corresponding like that, but since this blue triangle is similar and half the size of the black triangle we started with, we know that RS is going to be half the length of NQ by the same mid-segment theorem. What that means is we need to set 5x minus 39 times 2 in order to get it to the full length equals 4x minus 18. So that's really just showing us that RS is half of NQ. So we doubled RS to get all of NQ to set it actually equal to each other. So we get 10x minus 78 is 4x minus 18. We rearrange and solve to get 6x equals 60. X equals 10. And we now have measure of RS is going to say 5 tens minus 39 is 50 minus 39 equals 11. And just to double check our work, 40 minus 18 is 22, which is twice the length of RS, which is exactly what we want. So we want the length of RS for our answer, and that's going to be the one that is smaller, so it's going to be 11. Right here, it's the same kind of problem. One of these is half the length of the other. Do it the exact same way we just did that one. Um, don't give up whenever you're doing the problem because it's going to mark that as against you in terms of score calculation. But I'm going to do it because I get to do that without worrying about my grade in my class. So now we're going to go to next problem. This is actually going to be the same, but the other way around. So this time, we actually are going to solve the same way, but take the measure of the larger side. So we're going to double KL to get GJ, and then we're actually going to keep the value of the doubled one. So that should be pretty much all the things that you need to know for this section. So have a good one, y'all.